question 1, and based on the premise, we decided to use a yew tree with the average number of needles being 150,000. Some assumptions for the natural extract was the extraction method, which is high performance liquid chromatography, using the needles, the sex of the plant, tree height, and the average number of needles. The extraction process uses 2 liquids, which are then sonificated, centrifuged, and then it's placed into a HP, high performance liquid chromatography machine. The results show that the needle had the highest level of taxol extraction, and to calculate the average amount of taxol extracted, we assume that the average dry weight of a yew tree was 915,000 milligrams, which from this calculation we can see that the average amount was 32 milligrams of taxol.
The assumptions that we have for the dosage is that rats and humans have similar circulatory systems, so the clearance time is going to be the same, which was provided in the question is 3 hours. And the dosage of 1 milligram is going to be the same for all forms of cancer, and that we only take 1 dose per day based on FDA guidelines. So now we're talking about pharmacokinetics, which is the concentration of drug that reaches the site of action, and this is all to do with the chemical structure of taxol. So when comparing a rat versus a human, as the animal gets larger, the body surface area to body weight ratio decreases. So we can't lose heat as easily, and we can't utilise oxygen and calories as easily. So therefore, a dose that could be effective for a rat may kill a human. So as we can see here, while we weigh a lot more than a rat, we don't necessarily have that much surface area compared to a rat based on their size. So what we use is we use allometric scaling, which is scaling doses between species, and we use a KM factor, which is based on their body weight divided by their surface area. So if we divide the KM factors of a rat and a human, we get 8.1%, which means humans' metabolism only operates at 8% of a rat, and rats metabolize medication 12 times faster than a human. So if we use the equation where we multiply the KM factor of a rat, which is 5.9, and divide by the KM factor of a human, which is 37, we get a dose of 0.1595 milligrams for a human. So, as I said before in the assumptions, rats and humans have very similar blood circulations, so we're going to assume that the 3 hours provided in the question for the clearance of the drug is going to be the same for humans. And given FDA guidelines as well, we're going to assume that the daily dose is 1 dose, which is 0.1595 milligrams.
So some assumptions in regards to the structure of taxol is that taxol is a lipophilic molecule, and these lipophilic molecules are immiscible in polar solvents, thus the oral bioavailability of taxol will be low. So the structure of taxol is a part of the diatopian alkaloids in the genus Taxus. As you can see from the chemical name, it is a large molecule which adds to its molecular mass. Now, some chemical properties of taxol: it's highly lipophilic, as I said before, and it has a high melting point. Now, the way taxol works is to promote assembly of microtubules and prevent cell proliferation. So, due to the solubility considerations, however, there are limitations on bioavailability and extraction. Yeah, so as you can see here, there are a range of functional groups. The majority of them are nonpolar, and although while there are polar molecules, due to the bulk and arrangement of the molecules, it is overall nonpolar. There are ways to improve taxol solubility through various pharmaceutical methods. And just to recap, if you add, remove or replace functional groups, you can alter its bioavailability.
So our conclusions are that the dose for a human is 0.1595 milligrams, the number of daily doses is 1 dose is cleared from the blood in 3 hours, and the average amount of taxol extracted from a yew tree is 32.025 milligrams, which altogether calculates to an amount of daily oral doses as 200 doses. So the limitations we have is that we used averages, and we assume that allometric scaling accurately represents all drugs. In terms of ethical considerations, is it ethical to cut down a tree that lives for 400 to 600 years to prolong one person's life? However, they are toxic, so it's not destroying any animal habitats. So potential impacts: it does produce 200 daily oral doses, so it can prolong people's lives, so it's the importance of people's lives and the effect that it has on their family and community.